Hello everyone and welcome back. In the previous video, we went over the calculus subsection of the test drive and more specifically on taking derivatives, both implicit and regular derivatives. In this video, our focus will be also in the calculus subsection, but mainly on taking integrals, both bounded and unbounded. So the command is actually extremely similar to differentiate, and in this case is integrate. So to take an integral, we use integrate. The syntax is exactly the same. We just switch the name of the command. So we use integrate, the name of the function, and the variable in respect to. So in this case, let's say I wanted to integrate this expression, x to the fourth minus 3x squared plus 1. So first I make x into a symbol, then we set that equal to some letter or some name. In this case, I chose f, and then I say integrate f comma x. And here it is. This is the integral of the function f. Similarly, we can use the object-oriented syntax for the command integrate. So integrate is a method inherited by expressions that are functions. So function.integrate, and inside as a parameter is the variable. So f.integrate x will give us the exact same thing as saying integrate f comma x. So you might be wondering, well, can integrate do more complicated integrations such as use substitution? And the answer is yes, it can. So let's look at this expression. L equals log x squared over x. So you might be wondering what base log is, and the default is ln. So log base e. L equals ln x squared, or ln of x squared over x. And if we use integrate L comma x, we get the answer to be ln of x cubed over 3. Again, use substitution, no problem. So if we want to add bounds, we just add into the syntax that we already have. So integrate function stays the same, but inside we add the two parentheses and we add variable comma a comma b. A being the lower bound and b being the upper bound. So let's try taking the integral of h equals ln of x over 2x. So first, again, we define x to be a symbol, and we write h, and then we try confirming that we wrote h properly, and then we integrate. So integrate h comma x, lower bound being 1, upper bound being infinity. Infinity, we use it as the little double O symbol. So whenever you want to use infinity, just use OO. And again, this integral gives us infinity. If we write it into like an object-oriented syntax, we use h.integrate, kind of like we did h.diff. And in this case, we just write the parameters to be the variable, the lower bound, and the upper bound. And again, don't forget these parentheses. These two parentheses are very important. So if you forget them, it will pop out an error. And we can see again, that is the exact same answer. So in this part of the video, I want you to pause it and try it for yourself. Try taking the integral of this expression and then evaluate it from 1 to 3. Well, welcome back, and here's how we do it. First, we set x to be a symbol, so x equals symbols. Then we write the expression z is equal to e. Remember, we use capital E to express that Euler number. 1 over x divided by x squared. And then let's type z to see if we wrote it properly. We did. And then we use integrate command. So integrate. Let's use the function syntax. So z comma x. Oops. Go. Gives us negative e to the 1 over x. And let's try to use the other syntax, the object-oriented syntax. So z integrate with respect to x. And again, we should get the same answer. So that's how we check that we're properly using integrate. To evaluate, we just add in into our integrate. So integrate z comma, and then the parentheses, variable x comma from 1 to 3. we get e minus e to the 1/3. And then to confirm it, let's try the object-oriented syntax. So z dot integrate. And then again, x comma 1 comma 3. And there we go. So yeah, in this video, we learned how to take an integral, both bounded and unbounded. And in the next video, we're going to be going over how to save the document so that you can upload it to Moodle. So until next time, I'll see you around. Bye-bye.